Right. Hello, everyone. My name is Jose Alcerreca. We are going to talk about data binding today, but with a focus on 2018. We released the data binding library 3 years ago, and a lot has happened since. We released the architecture components, view model, live data. They work very, very well with data binding. Also, we detected some patterns that are good, and some practices that are not that good. So we're going to talk about those today. So the nice thing about data binding is that you can use how much you want of it. Well, this is the list of features we're going to talk about today. And I group them in 3 tiers, so beginner, intermediate, and expert. Obviously, I recommend you to go at least to the intermediate level. But we're going to talk today about avoiding calls to find view by ID, layout expressions, the layout expression language, and some static data binding. Then we're going to talk about the most important topic, which is binding adapters. I'm going to show you where to find the provided adapters and how to create your custom binding adapters. Then we're going to talk about observability, in case you want your UIs to react to changes in data. There are 3 elements or 3 components for that: observable fields, live data, since Android Studio 3.1, and observable classes. And then we're going to talk briefly about two-way data binding, which is the hardest part by far. So let's talk about data binding in general first. The concept has been around in the industry for decades. Actually, if you Google data binding, you will probably get Angular results from Stack Overflow or .NET or other platforms. So without data binding, you are going to be used to something like this. In your presenter or in your controller or view model, you receive new data, and you have some way to tell the view that it has to be updated. Then, for example, in the activity, you have a method, in this case, setName, that takes a string. The activity is responsible for finding the view that it has to change, and then assigning a new value to an attribute. In this case, name to the text attribute. Now, data binding is not about doing this. It's actually about avoiding UI calls. It's more about configuring what you want to show on a screen. In this case, what we're trying to tell our data binding mechanism, whatever it is that I have a user with a profile picture and a name, and I want to show a layout that has an image and a text, and those are connected. Now, in the data binding library in Android, we can do this in basically 3 steps. First, well, you have to set data binding up. So just go to the documentation. It's just 1 line of code that you have to add to your build Gradle file. The second step is transforming your layout into a data binding layout. And you do this with these 3 steps here. You first wrap your layout in a layout tag. So layout is a data binding layout. You will probably have to move your namespaces, because this is still an XML document. Actually, there's a shortcut in Android Studio to do that for you automatically. Then the second step is to add layout variables. This is optional. Normally, well, 80% of the time, you will probably just have 1 variable, which is going to be ideally a view model, and ideally from the architecture components. And finally, you add as many layout expressions as you want. So in this example here, I'm going to get out of the way, we are binding the name exposed by the view model to the text attribute of a text view. Now, on the view side of things, and when I say view here, I mean activity or fragment or whatever, instead of inflating the layout in the usual way, you have a couple of ways to do this. Here's one, data binding util.set content view. If you pass a data binding layout to that method, it's going to return a profile binding. This is the most important part of the library, is the generated code. This class, which I recommend you take a look at it, is going to be responsible for doing the heavy lifting for you, basically. For now, we're just going to create our binding. This object has references to all the layout variables. So the next step that we have to do is obtain the objects that we want to bind to those variables. So in this case, we're just obtaining a view model from architecture components. And then you do the actual binding, which is simply assigning the object to the layout variable. And that's it. You don't have to write any UI calls. Of course, this gets complicated. This is my plug. Actually, we just released 2 data binding samples, the official samples, on this GitHub repository. They have very comprehensive READMEs. They explain every feature that is showcased in the samples. So make sure to check them out. If you find problems or you want to file requests, feature requests, just create issues on GitHub. Now, features. Let's start by the first one. The first feature of data binding is not actually a feature. It's more of a byproduct of another feature. I said that in the generated binding, there was a reference to every layout variable in your data binding layout. But also, there's a reference to every single view that has an ID. And this is very handy. In this case, we have a data binding layout with a constraint layout and 2 text views with IDs, name and last name. This is very simple. From your binding object, you can access those views just by specifying their IDs. That's it. This is not actually a binding. We're actually just assigning a value to an attribute of that view. So since you're here and you've already set data binding up, why don't you just add some layout expressions? I showed you what a layout expression was, but I didn't really define it. So an expression is something that lives in the value of an attribute inside an XML element. It is wrapped by those curly braces and prefixed by an @ symbol. And the language that you can use inside that expression is actually really, really powerful for template language. You can do math operations, string concatenation, field access, array access. You can even do ternary. You can have ternary operators. But when we released data binding 3 years ago, the first piece of feedback that I got from a developer was, this looks good, but logic in the XML, that's horrible. I don't want that. And I totally agree. I think everyone agrees. An XML document is not a place for code. It's just for configuration and for connecting points, basically. So you should think about layout expressions as wiring, as I want to connect element A with element B, and that's it. We'll talk a little bit more about this later. So let's see some examples. The first one is really straightforward. I'm assigning a variable to a text attribute in a text view here. So that expression is a string, probably, or a sequence of characters, or returns a string. Now, the second one is just field access. This is completely fine to do inside a layout expression. The third one is more interesting. This is actually a lambda expression. So when the user clicks on this text view, viewModel.onLike is going to be called. We'll talk about lambdas in a second. Now, the fourth one is interesting because height if 0 is not an attribute of text view. It doesn't exist. This is probably my favorite feature of data binding. You can create your custom attributes. So in this case, if viewModel.likes is 0, the view is going to be hidden, made invisible, or gone, or whatever. Now the fifth one, what's going on here? It looks like it's an image view, and it's assigning something to source compat. Looks like if the number of likes is less than 4, then it's going to show a person icon. Otherwise, it's going to show a fire icon thingy. This is completely unreadable. This is not testable. The layout language is powerful, but not that powerful, because this is still an XML document, and you can't put a less than symbol inside an expression, so you have to use this ampersand LT semicolon thing, and then there's a for, which, what happens if you want to refactor that? It's completely hidden from the rest of your logic. So this is a very bad idea. You would, instead of doing this, you would just create some method in the view model and just call viewModel.get icon or something, or popularity icon or something like that. All right, let's see some more examples of lambdas. The first one I showed you in the previous slide, I didn't talk about the parameters that you can use in the onClick attribute. Here, we're receiving a view in the lambda, and we're ignoring it and just calling onLike in the view model. This is a little bit different from Kotlin, for example. If you're not going to use the parameters in your lambda, you can just not write them. In Kotlin, you would use underscores, etc. In this second example, we are calling the onLike method, and we are passing the text attribute of another view. Remember when I told you that the first feature wasn't really a feature, it was a byproduct of another feature? I think that's where this comes from. So you can refer to other views in the same layout by their ID inside a layout expression, which is very nice if, for example, you're doing, I don't know, a form validation. So submit button would have something like that, and you would pass the text attributes of the user and the password fields. The third one, this is, really straightforward. If you have access to viewModel, which is a variable in a lambda, in a layout expression, of course, you have access to all the variables in your same layout. And then the fourth one is the interesting one. This is a check button, and we are assigning something to the onCheckedChange attribute. And this is the lambda that you have to write. It receives a compound button or a check button as first parameter, and as a second parameter, it receives an isChecked Boolean, and then it's calling the check-change method with a task, which is another variable, and the isChecked Boolean. So this is what really frustrated me when I first started with data binding. And the question is, where is this coming from? So I'm going to make a very dramatic pause here, because I want you, because this is the message of the talk. There is no magic in data binding. In order for you to use data binding, you have to understand where the magic comes from. So I'm going to try to explain it to you. 80% of the magic is in here, binding adapters. Super important topic, and I'm going to spend like 50% of the talk on this. So remember when we took this for granted, right? Remember when I told you that if the layout expression returns a string and we apply it to a text attribute, that is going to be shown, like displayed on the screen? Well, data binding is not doing anything magical. It's actually calling setText somewhere. So the question is, where is it? It's actually here. This is a binding adapter. It's a static method. It's annotated with binding adapter. The binding adapter is receiving Android text as a parameter. The first lines of code, they're just checking for changes. That's it, so that we don't generate too many unnecessary UI calls. And then on the last line, it's just calling setText. So it's not doing anything magical. You just have to find it. Now, let's define a binding adapter a little bit better. It's, again, a static method. It's annotated with binding adapter, and it receives one or more attribute names. Let's just simplify for now and assume that there's only one attribute name. The method is going to get a view as the first parameter, always. And the second parameter is going to be matched against the attribute. So when you do something like this, data bind, this is a layout expression that returns our char sequence, by the way. Data binding is going to search for a binding adapter that is available somewhere, it doesn't matter where, that matches these three requirements: text view, or a subclass no, or a superclass of text view in the binding adapter, Android text attribute, and char sequence. So it's going to look for something like this. Now, what happens if we return something else from the layout expression? Let's say we return a user, a custom class. Then it's going to look for something like that. The second parameter is going to be a user. If that binding adapter doesn't exist, then it's going to break at build time. This search that I told you about, is made at build time, so you don't get like runtime performance penalties or anything like that. Now, the method name is completely irrelevant, or not used, rather. And you can call them banana if you want, but it's actually a good opportunity to explain what's going on inside the binary adapter, because it can get a little bit complicated. All right, so finally, I'm answering the question from like 6 slides ago. This is the binding adapter that is provided by the library for the compound button, checkbox. A check button is a compound button, which is applied to the onChecked change attribute. Now, the interesting thing is that the second parameter of the method is a listener, and lambdas are translated or are transformed into listeners. This particular method is using the onCheck change listener interface, which is not part of data binding. This is actually part of the framework. This is what the compound button uses, and it's a single method interface. And this is where the Boolean comes from. Now, if we look at the method, what they're doing is just setting a new onCheck change listener, and then when the value changes, it's calling the listener, the listener parameter, and passing the button view and the isChecked parameter or value. Now, that listener, as I said before, is your lambda expression from the layout expression. So it's just calling the body of your lambda expression. That's how we connect to the view model. All right, just very briefly, if you use Kotlin, you might want to put your binding adapters inside an object, because that's like the Java way. But if you do that, then the method is not going to be translated as a static method. So for that, you have to add the JVM static annotation. Now, if you want to be a little more idiomatic, you can do this, which is just use the top level of a Kotlin file. This will be compiled into a static method. So this is the list of provided binding adapters that we offer in the library at the moment, at least. As you can see, they did a lot of work with these things. If you want to take a look at them, I recommend you starting with a compound button binding adapter. You'll see that what I show you was actually a simplification. But other interesting ones are image view, text view, view binding. Actually, when I think about the data binding library, I think of 2 things: the mechanism that generates all the code for you, all the boilerplate, and a collection of binding adapters. But they are no different from your custom binding adapters that you might want to write. So where are these binding adapters? How do I find them? They are in this very friendly URL. Don't take a photo of this. I'm trying to surface this into the docs because they are really hidden, and I don't know why, because it's a very, very good resource to have. So my trick for now is I just Google TextView binding adapter.java and I find it. But yeah, stay tuned for changes in the documentation regarding that. So binding adapters are super, super important. I could be talking about them for 2 hours. So I'm going to go very quickly through the rest of the features that they have. So if your binding adapter is really, really small, it's just like 1 line of code that calls a method on a view, you can use a binding method. It's just a shortcut. This is very handy for the library maintainers, but not so much for us. I mean, we're not going to save that many lines of code by doing this. So just so you know, and you might see in the provided binding adapters, you can take this shortcut. Converters, same thing. If your layout expression is returning type A and your binding adapter is expecting type B, and there's a converter from A to B, then it's going to be automatically used. But again, it's not going to save you a lot of time because it's just probably one line of code that you would have to add to your binding adapter. So just so you know, they exist. Now, there's another interesting feature that you might not even want to know about because it's very uncommon. You can actually get access to the old values of the attributes that the binding adapter uses. So you just duplicate them. The first one is going to be the old value, and the second one is going to be the new one. This is handy, especially for listeners, if you want to make sure that the old listener, that you can remove the old listener from a view or something like that. But again, it's not very common in your custom binding adapters. This is another one of my favorite features of data binding. You can use multiple attributes in one binding adapter. So in this case, we have an image view with an image URL attribute that's probably a string, and then a placeholder attribute that is a drawable. Now, note here that this drawable, the value, is still a layout expression. You have to wrap it. Otherwise, if you put that drawable there directly, then the system is going to look for a placeholder attribute in the image view and it's going to fail because it doesn't exist. So remember that even if you're just using a primitive or a drawable or something like that, you have to use the wrapping and the add symbol. This is how the binary adapter would look in Java, at least. We specify the two attributes in the value parameter of the annotation, and then we just put them in the method, in the static method. We are receiving a string, a URL as a string, and then a drawable, which is the placeholder. Now, require all is an optional parameter that is true by default. And what that's going to do is, if it's true, it's going to wait for all the attributes to have a value. Otherwise, it's not going to call this method. If it's false, then when any of those parameters are set, it's going to be executed. So in this case, you can bypass the image URL. You can not define it in the XML, and it's just going to set the placeholder. If both, or if the URL is available, it's going to call your image loader library, Glide or Picasso or whatever, and it's going to load the URL. All right, this is a very important concept. When are binding adapters called? They're called on bind, so the first time you define the connections, if require all is OK with it, of course. And then they are called when an observable value changes. If, again, require all is OK with it. So the next feature is observability. But first, we need to talk about architecture, because there's a really important thing about data binding. This is our presentation layer now. There's a view model. We have a bunch of layout expressions, and they connect directly to binding adapters, and these are the ones that make the UI calls. Now, no matter what book you read about architecture or what pattern you like, they all kind of agree that you always have to keep your views dumb. And that means that you shouldn't have any logic in activities or fragments. You should hold or try to minimize the amount of state that you have in them. So basically, they act as something that bypasses calls to the framework. Now again, where's our view in this diagram now? When I say view, I mean MVP, MVVM view. It's basically the combination of the layout expressions and the binary adapters. So are we keeping our view dumb? Well, actually, we know that the layout expression language is limited. And also, I told you that it should be very, very limited. And then we know the binary adapters are just static methods that, small snippets of code that are very isolated from the rest of your app. well, they receive the view as the first parameter, and you can access the whole context from there, but obviously you shouldn't do that. So basically, by using data binding, we are obeying that law. We are making our views very, very dumb. And you might think, well, I'm a seasoned developer. I don't need to depend on data binding just to keep my view dumb. But think about the junior developers that might join your team. They are going to be forced to follow this pattern. And I think it's a very good pattern. Now, the activities and fragments, also they are very dangerous territory because they can be destroyed at any time. They still have some responsibilities. If you use data binding, they still have to inflate the layout. They still have to obtain your view model or a presenter, whatever. They still receive the lifecycle callbacks, although now with architecture components, you can make your components lifecycle aware. They will probably handle navigation. And there are some UI calls that are a little bit tricky from binary adapters. So snack bars, for example, is a good place to do, or the fragments or the activities are actually still a good place to handle showing snack bars. So as you can see, they have lots of responsibilities. So if we can remove code from them, that's always welcome. So now we can talk about observability. We have 3 options for observability. Observable fields, the replacement, you could say, which is live data, which is basically an observable field, but lifecycle aware. And observable classes, which is the most advanced of them, and the one that gives you more flexibility. So let's see this with an example. Here we have a view model. It has a variable, which is a string called name, and it has an observable field called last name. Now, when your view model loads new data, it's assigning the new value to the name variable, but data binding has no idea that this happened. So it needs a way to know that there's something to update in the UI. If we use observable fields, that set method is going to call all the observers and tell them that something changed. Well, not something, that particular property. So doing this is actually really hard. This is real code from the generated binding, the binding class that is generated by the library. Coding this is really hard. You don't want to be doing this. It actually uses a very complicated, but actually readable, mechanism of dirty flags. The good thing about generated bindings is that you can set breakpoints, and you can debug it, and you can read it. They actually add comments to the actual code. By the way, I should mention that in Android Studio, if you want to see the binding, there's a setting to let you access that file. For some reason, by default, it shows you the XML layout. So yeah. Live data, very, very similar to observable fields. In this case, I'm showing the recommended pattern. So it's always a good idea to expose an immutable version of an object. So here we're using a backend field, which is mutable, and exposing the live data, which is immutable. And then when the data is loaded, we just post the value or set the value on the backend field. This is exactly the same as set in observable fields. So why would we use live data? Because they have a lifecycle owner. They are scoped to a specific activity or fragment or lifecycle owner, so that when they are not in resume or post state, they are not going to receive updates. So it's a little bit more efficient. Now, there's a new thing that you have to do. You obviously have to tell data binding which lifecycle owner to use. And you do this by simply calling set lifecycle owner on the binding object. Now, observable classes. The most advanced way of implementing observability in your app. You have to do 3 things. Implement the observable interface, or extend the base observable class. Annotate the properties or the getters of the properties that you want to make observable with bindable, and then trigger the refresh with notify property changed. So this example is very similar to the first one when we were assigning a a new value to a string. So you have to first annotate the getter of this field with bindable. That is going to generate a property in your base observable class. Now, when we have new data, we change that string, and then we tell data binding by calling notify property changed that something changed and the UI should be updated. So that BR class is also auto-generated, and it gets the names from actually the getter. So I think it does some kind of transformation. It removes the get, and it does lower camel case with the rest of the method name, I think. Now, when would you use this? Especially in two-way data binding. And this is the most advanced part of data binding, of the data binding library, I think. And it's all about, again, removing lines of code. In one-way data binding, you would do something like this in order to write and read in a view. In this case, we have a checkbox, and the checked attribute is bound to the view model.rememberme field, or whatever that is. And then when there's a check change, the view model is going to be called. Remember me change is going to be called. So this is two ways, but it's just one way. It's just like two different binding adapters. Now, the idea behind two-way data binding is that you do this with just one attribute. So we can use checked and the new format for two-way data binding, which is @equals and then the curly braces. Now, this is actually straightforward for a checkbox. In our base observable, we need a getter and we need a setter. The setter is obviously going to be called whenever the user changes the value of the check button, and the getter is going to be read and assigned to the checkbox every time the data changes. There is a very important concept in two-way data binding, and that is to avoid or to break infinite loops. The problem is, if the data changes, then the layout is going to change, which is going to trigger a call to the setter, which is going to change the data, which is going to change the layout, et cetera, et cetera. So you have to break that chain somehow. A good place to do that is here in the setter. So what we do is we check for a change. So if the value is different, then we change the backend field, we save data, maybe we save to the database or something like that, and then we notify that the property changed so that the getter is called and the UI is updated. Now, if you want to create binding adapter for two-way data binding, then things get really complicated because you have to tell three things to the Android data binding library. What to do when data changes. This is a straightforward binding adapter. But then you have to tell it when the UI attributes have changed, and then what to do when the UI attribute changes. Basically, get the value from the view. For that, you have to create an inverse binding adapter, and it gets really complicated. We have a two-way data binding sample on GitHub that explains some of these things. So you have very simple two-way data binding. You have custom two-way data binding, one-way data binding, animations, and many, many other things. The README, again, is really comprehensive. So check it out if you're interested in creating these binding adapters. And that's all from me. I'll be around the conference if you need anything. And yeah, make sure to check out our GitHub repository. Thank you very much.